Okay, this video is to finish up section 8.1. Today what we're going to do is go backwards and write the series in sigma notation. So now we're going to need to come up with the equation, and not only that, but we have to figure out like if I have n equals down here, what would be the beginning thing I would need to plug in and what would need to be the last thing I plug in. So look for patterns, look to see if something is arithmetic or geometric. Yeah, so that's what we're gonna try 3 examples here. So this first one, when I'm looking at it, I notice all of them are fractions, so I would just make a fraction bar. I notice that the tops are always a 5, so I'm just going to write a 5. And looking in the bottoms, the denominators, I notice it's always 1 plus something. So that's what I'm going to write, 1 plus something. And here's what I'm noticing. I'm adding a 1, then I'm adding a 2, then I'm adding a 3, all the way up to adding a 15. So it looks like that is the thing that's changing. So I'm going to give that a letter. And it looks like the first thing that we are plugging in to that letter, the first thing that's being plugged in is a 1. And what is the last thing being plugged in? It's a 15. And there's my formula. So it looks maybe more complicated than it needs to be. Just look for those patterns, especially if it's a fraction. Look at the top separate from the bottom. This next example, I'm noticing I've got fractions. I'm noticing they're alternating, positive, negative, and so on. That means there's going to be some negative term to a power, because negative terms to odd powers are negative, negatives to even powers turn positive. So I know that that's going to be involved. But here's the other thing I'm noticing. It looks like every time I get to the next number, I'm multiplying by 1/2. Actually, negative 1/2. 1 times negative 1/2 would be a negative 1/2. Negative 1/2 times negative 1/2 would be a positive 1/4. 1/4 times negative 1/2 would be a negative 1/8, and so on. So since I'm multiplying by the same thing each time, if I notice that, then I can say to myself, oh, that's geometric, and I've got a formula that I can use for geometric. Our general formula is a sub 1 times r to the n minus 1. So I'm going to follow that formula, and I'm just going to put it in sigma notation. My first term is a 1. The thing that I'm multiplying by each time is r, that's negative 1/2, to the n minus 1. Now I need to figure out where do I start my n and where do I end at. So if I plug a 1 in to begin with, if I plug a 1 in here, my exponent would be a 0. Anything to the 0 power is 1. Times 1, my first term would be a 1, and that checks out because my first term is a 1, so that's looking good. Now the thing that I need to figure out is what is going to go up here so that I end up with a negative 1 over 128. So I could guess and check. I could like plug in a 5 into this formula and see if I get negative 1 over 128. Or I could keep plugging in numbers until I figure it out. Or I could start at negative 1/8 and keep multiplying by negative 1/2 until I get here and keep track of how many times I had to multiply by negative 1/2. That could also work. Or what I could do is basically take my formula and solve for n if I set it equal to that term that I'm trying to figure out. I'm trying to figure out n. I'm trying to figure out what term gives me negative 1 over 128. Now, 1 times this, I could just write it as negative 1/2 to the n minus 1. I don't really need that 1 out in front here. Now, if I'm going to solve that, This is an exponent, and the only way to solve that would be to use logarithms. So if I do log starting at the base, so log base negative 1/2 of negative 1 over 128 equals n minus 1. If I go to type this in my calculator, I'm going to have some problems because I can't have log of a negative number, and I also can't have a negative base. So your calculator is going to kind of freak out at you. Here's what you need to just be aware of. This being a negative is just because of the alternating signs. The term number would be the same even if this was a positive value. So what I'm going to do instead is type this in but with positives, because all I'm looking for is the term number. Oops, I meant that to be a positive. Okay, so now if I type this in my calculator, I'm going to get 7. And then I would add 1, so that means my term number is an 8. So that's going to go up here. This will be an 8. Okay, now, if you're wondering or worrying about the fact that that was negative, plug an 8 in here, okay, and you'll have negative 1/2 to the 7th power, which will be negative. So it all works out. It's just that alternating positive, negative, and so on. So you can guess and check. You can plug values in for n until you figure out what equals negative 1 over 128. Or you can do it like the algebraic way like this, where you actually solve for n. Doesn't matter to me which way you do it. All right, here's the next one. First off, see if you can establish a pattern at all. When I look at these numbers, it looks like I'm adding 4 each time. And that's a really good thing because that means it's arithmetic. And we have a generalized formula for that. Now, you might be wondering, why am I not using the other formula, this formula right here? There's 2 formulas for arithmetic. This is the summation formula. This is what I would use if I wanted to find the sum. But that's not what it's asking for in this problem. I'm not asking to find the sum. I'm asking just for an equation in sigma notation. So this is the formula I'm going to use. It's a generalized formula. A sub 1 is my first term, which is a 3. D is the common difference, the thing that I'm adding each time, which is a 4. All right, now what would n have to equal so that my starting term is a 3? It would have to be a 1, because if I plug a 1 in here, this will be a 0 times 4, which is 0, plus 3 would be my starting term of 3. So I start by plugging in a 1. Now what I need to figure out is, how far do I need to go up to get to a 47? So I could just keep adding 4 until I get to 47 and figure out how many times I had to add 4, and that would be this top number. I could do that. Or I could approach it algebraically, take my equation and set it equal to 47 and solve for n. So if I distribute the 4 through and I combine like terms and then add the 1 and divide by 4, I'm going to get a 12. So this top number up here, which was a question mark, now I know should be a 12. And you can always double check that, plug a 12 in for n. 3 plus 4 times 12 minus 1. I should get a 47. So 3 plus 44, yep, that's 47. That works. When I plug a 12 in, I get a 47. So I'm just writing generalized summation notation. I'm not actually finding the sum. I'm just writing the equation. Oh, and it would be totally fine as well if I wanted to put this in a more simplified form. So maybe I'll write it up here. So like instead of 3 plus 4n minus 1, if I distribute the 4 through and then combine like terms, I would have 4n minus 1 in parentheses like that. I should also do that here. I should put that in parentheses so I remember that all of this gets summed up. Do I need to do that? Geometric? No, that's fine because I'm multiplying. And here, this was fine. I wasn't adding or subtracting terms. Like I am here, I have several terms I'm adding up. But yeah, so today is going backwards and coming up with the summation, the sigma notation. So try to see if it's arithmetic or geometric. If it is, you've got formulas you can use. If it's not, you have to just look for a generalized pattern. And those ones will be a little trickier. And also know that there's more than one right answer to all of these too. So yeah, just give it your best shot. It's a little trickier going this direction. Come to office hours if you need some help. Okay, bye.